Take care. தண்ணியில எடுத்து உட்கார்ற குடிக்கிறதுக்கு சும்மா வந்து என்டையர் கிளாஸ் சும்மா ட்ரையாக உட்காந்துருக்காங்க. Bring water bottle. அப்பப்போ கொஞ்சம் தண்ணி குடி, சரியா? சரி. எஸ். How we will plan the today's class schedule? I think already we have finished revisions. Am I correct? So no need to give a revision. But today we have a test. Let me show only the titles. The class mudinji immediate poi ukandhu full from the scratch. You are not going to study. Okay. Let me just show the titles alone to refer you to the things. Okay. நிறைய பேர் படிச்சிருப்பேன், எல்லாம் படிச்சிருக்கியா ஒரு தடவை செக் பண்ணிக்கலாம். ஓகேவா? So screen is visible, sir? So screen is visible?
Yes, sir.
Okay. என்ன பண்றாங்க? What process it is?
Testing, sir.
Testing of what?
CA2.
See, that is we are going to do. Okay. So actually the strip test பேர் இருக்கு. ஓகேவா? So strip testல இதுக்கு முன்னாடி you have pre-process. They will take the sample, then they will mix, then they will fill it in the tube, then they will put only few drops in this strip test. My question was, by having this little small sample, how it will give you the you have indication also. Am I correct? That is hidden. In that it will show whether it is a positive or negative. Okay, so whenever they are doing the particular process, the temperature are very, very important. Okay, the particular temperature they have to do this process. My question was whether do you have any electronic components inside the strip? Nowadays, if you listen any few WhatsApp videos, the strip, first of all, you need to tie up with your mobile. Am I correct? You need to pair with your mobile app. Then whatever the process happening here, it will send to your mobile phone as well as the particular company server. Have you seen such kind of video clip in the WhatsApp? Am I correct? Have you seen? So that means that something present inside this strip, there are some electronic components present over here. Okay, that will get interact with your mobile phone, means there will be some wireless communication. Okay, that and all. Please think and browse whenever you find free time. In the same way, only the drop we are going to ask as a question. Am I correct? So even though you have a plenty of things in your syllabus, only the limited thing will be asked in your question to test your knowledge. Okay, your knowledge test பண்றதுக்கு தான் இந்த process. Do you give somebody's sample to test the COVID? Never. Am I correct? So I want to know whether I affected. I need to give my sample to test. Okay, please. We people are expecting in the CA2, you will test your sample. Am I correct, sir? Am I correct? Try பண்ணலாமா? 0 வந்தாலும் பரவாயில்லை, உங்களுக்கு என்ன தெரியுதோ think பண்ணி அதை மட்டும் எழுது. Okay. We never give other sample to test. Am I correct, sir? வாயே திறக்க மாட்டேறான், ஏத்துக்கவே மாட்டேன்றான். இல்ல சார், சிஏக்கு மட்டும் நாங்க ஒரு 4 பேர் வச்சுக்கிறோம். அப்படிதானடா? 4ல 1 கரெக்டாடா? அப்படிதானே? சரி, ஓகே. போர்ஷன்ஸ் என்ன இருக்கு? ரொம்ப சிம்பிள். கன்ஸ்ட்ரக்ஷன் பார்த்துருப்ப பிஜேடியில், தென் அதோட ஆப்ரேஷன், தென் the early effect one thing, then the configuration and characteristics, followed by BJT biasing. Okay, இது வரைக்கும் முடிச்சாலே almost BJT covers. And one more thing, already you have finished this one in your unit test 1. So already 50% of burden you have finished. What are the new things? The small signal amplifier and the frequency response. Then what? FET. FET MOSFET only we are going to focus. In that you have two types: E MOSFET construction and operation. Then D MOSFET, E MOSFET order drain and transfer characteristics, followed by D MOSFET. Then biasing of E MOSFET. Then biasing of D MOSFET. The last one is the amplifier. So up to this frequency response you have it, and don't worry about this last topic much. Okay, so all the best. We are expecting your sample as answers. Okay, sir. Shall we try today? Yes. Okay. Where is our last class discussion? Can anyone tell me where we stopped our last class discussion? என்னடா கரெக்டா இருக்கனா? கிளாஸ் ரெக்கார்டிங் போயிட்டு இருக்கா? ஸ்கிரீன் விசிபிளா இருக்கா? இல்ல எல்லாம் படிக்க உட்காண்டியாடா? இல்ல யாரும் பண்ண மாட்டாங்க. ஹலோ, எஸ் என்ன சித்தேஸ்வரன் ரிவிஷன் போயிட்டு இருக்கா? சரி, ஓகே. வேர் வி ஸ்டாப்ட் அவர் லாஸ்ட் கிளாஸ் டிஸ்கஷன். யோகேஷ் என்ன பண்ற? நிறைய பேர் பேரே தெரியலடா. நமக்கு செமஸ்டரே முடிய போகுது. கரெக்டா? Next semester definitely we are not going to meet in your class hereafter. Okay, maybe this is the last paper, first and last paper for us to interact. But unfortunately I don't know many of the students in this class. I don't know your abilities. See, many of the time we people are showing the works done by the people who we knows, others not interacting with us, so we are unable to do that. Okay, can anyone tell me where we stopped our yesterday's class? Yes, konja quick.
Frequency response.
Frequency response in
MOSFET amplifiers.
Okay, MOSFET amplifier oda mudichama. Multistage amplifier start panna mari theriyude.
Yes sir, started cascade arrangement.
We started some discussions regarding your multi-stage amplifier. Am I correct? So what is the today's date? So today's date, you see, 2/9. Am I correct? 9/6/21. Please take down the date and start right. Yes, multi-stage amplifier. Why we need multi-stage? Why not single stage? Why I need to add the more than one stage in my amplifier circuit? Any idea? Last class we have seen few. Yes.
So to get a high power output.
See, last class we have saw few things. The 2.1 watt speaker and 150 watt speaker. Am I correct? So these are all the output component what we will connect it in our amplifier. Am I correct? In the amplifier output lender only these kind of speakers. Most of the time, whenever if you are talking about the audio signals, there are few cases even we will connect few instruments and some processing units like that. You have many applications. Okay. So if you think about the ICU or some other medical care system, from the human body, they will measure various signals, then they will amplify it, then they will give it to some display unit. Am I correct? So likewise, you have plenty of applications for the amplifier, but we stick with the audio signals most of the time. Okay, especially in our discussion. Okay, so if you stick with only audio signals, I have different wattages. Am I correct? So if I want a single person have to listen some audio, 2.1 watts is sufficient with the shortest distance. Am I correct? If the distance is increased, even for the single person, the 2.1 watts speaker is not sufficient to deliver the sound energy. So at the time we will go with the high power rating speakers. So if you see some public addressing systems, there they will be used hundreds and thousands watts speakers to deliver the high sound energy. Am I correct? So if that is the case, it is not possible to go with a single stage. So single stage can help up to this. But if I'm going beyond this, I need to go with the multi-stage amplifiers. So what are the things we are going to discuss over here? Already we discussed these two things, am I correct? What is multi-stage amplifier? The amplifier consists of more than one stage, that's all. Cascading means what? One after another. It is like a series, am I correct? First stage, second stage, like that we will connect the amplifiers one after another. Thereby, the first amplifier will helps little bit and gives the input to the second. Then second will amplify and it will give the input to the third. If it is a three-stage amplifier, at last you will get the output. Sir, இது மாதிரி இதெல்லாம் என்ன சார் எங்கிருந்து சார் கண்டுபிடிச்சாங்க? ரொம்ப சிம்பிள், ரொம்ப சிம்பிள். See, you know, the birds are flying kilometers and kilometers. Am I correct? Birds. எவ்வளோ கிலோமீட்டர் டிராவல் பண்ணும் per day? ஒரு கிலோமீட்டர் டிராவல் பண்ணிட்டு ரெஸ்ட் எடுத்துருமா? எவ்வளோ கிலோமீட்டர் டிராவல் பண்ணும்? Anyone knows? Birds எவ்வளோ கிலோமீட்டர் டிராவல் பண்ணும் per day minimum? அது various category இருக்கு. Am I correct? So minimum you take it as a 10 kilometer travels in a minimum. If the single bird flies for 10 kilometer, there are some birds can fly up to 10 kilometer with a single. But if you observe the sky during morning and evening time, you will find the group of birds will fly. Am I correct? Enna shape la fly agum? Can anyone knows? Enna shape la fly agum theriyuma? Group of birds இப்படி fly ஆகும் பார்த்திருக்கியா? V shape ல. Am I correct? என்னடா இன்னைக்கு மௌன விரதமா? இன்னைக்கு என்ன கிழமை? புதன்கிழமை மௌன விரதமாடா? ஹலோ? இல்ல ஏதாவது சீரியல் போயிட்டு இருக்கா? ஆனா இது மாதிரி பார்த்திருக்கீங்களா பேர்ட் fly ஆகுறதா?
Yes, sir. Yes,
இது
sir.
என்ன கான்செப்ட் சார் இது? என்ன கான்செப்ட்? ஸோ இப்போ என்ன ஆகும்? இங்கே தான் ஏர் வந்து ஃபுல்லாக அடிக்கும் ஃபர்ஸ்ட், அப்புறம் இதுக்கப்புறம் டைவர்ட் ஆகும். ஸோ all the birds will form one bird structure. Am I correct? இது put together பார்த்தீங்கன்னா ஒரு bird மாதிரி இருக்காது. Am I correct? ஸோ இது ஒரு மல்டி ஸ்டேஜ் மாதிரி இருக்கா? ஸோ இண்டிவிஜுவல் பேர்ட்ஸ் வந்து it will divide the effort to travel. Am I correct? So frontல இருக்கிறது should be more energetic. Periodically they will change, they will shift their positions. தெரியுமா? ஸோ இதெல்லாம் கொஞ்சம் பாரு, நல்ல ஜியோகிராஃபிக் சேனல் பார்த்தீங்கன்னா தெரியும். ஓகேவா? ஸோ ஃபர்ஸ்ட் லீடர் போயிட்டே இருப்பாரு, கொஞ்சம் இவருக்கு தான் இவர் சீக்கிரம் டயர்ட் ஆயிடுவார். கரெக்டா? ஸோ டயர்ட் ஆனாலும் இவர் பொசிஷனை மாற்றிக்குவார். பொசிஷனை மாற்றி ட்ராவல் பண்ணிட்டே இருக்கும். அட் த சேம் டைம் ஏதாவது ஒரு பேர்டு டயர்ட் ஆயிடுச்சுன்னு வச்சுக்கோ, அது இதை விட்டு வெளியே வந்துடும். வெளியே வந்துட்டு பார்த்தீங்கன்னா இப்படி ரெண்டு பேர்டு அசிஸ்ட் வச்சு கூட்டிகிட்டு போயிட்டு இருக்கோம். அப்புறம் அது ரெடி ஆனதுக்கு அப்புறம் they will synchronize with this. So this is the என்ன சொல்றது, டீம் எஃபர்ட்னு சொல்லலாம். The multi-stage amplifier also it is going to the same fashion that the individual amplifier doesn't have energy to drive big thing. If you cascade few stages, it will give sufficient energy to drive. Okay va? சரி, அப்போ மல்டி ஸ்டேஜ்னா மோர் தேன் ஒன் cascade one after another சீரீஸ்ல போகுது. Then we will discuss these three parameters, these three titles in detail in the today's class. Okay? Yes. Now I know these answers. If anyone absent last class, please note down this definition alone. It's very important. Very important. Only this keyword is sufficient. More than one stage amplification is called as a multi-stage amplifier. Is it okay? Is it okay? Yes. So then what? This arrangement is called what? Cascade arrangement. Okay. Can anyone tell me? Is it only the transistors or that amplifier circuits alone is sufficient to make the multi-stage amplifier, or else we need any one component to introduce between the two stages of your amplifier? If there is any new component, I need to place in between the two stages of amplifier. Yes. Is it possible to
RC coupling and transformer coupling?
Okay, in general it is called as what? Coupling circuit. Am I correct? I need to place one coupling unit in between the two stages of our amplifier. Okay. Yes. Then this is one typical example. Can anyone tell me how many stages are there in the circuit diagram? How many stages are there?
3 stages, sir.
How you are telling it is a 3-stage? What is the
Sir,
clue?
we have 3 sets of amplifiers, sir, connected through capacitors.
Very simple. It is a transistor amplifier. Am I correct? So hereafter, we will name this amplifier with mainly two things. One is the type of component or the device used for amplification. What type of component is used over here? What is the name of the component?
MOSFET, sir.
Hello, Siddheswaran. முடிஞ்சு போச்சு போல் இருக்கு CA2.
Sorry, sir. BJT.
இந்த இதுதான்டா இந்த பத்தி இந்த அப்ஜெக்டிவ் டைப்ல இதுதான் மேட்டர். அப்படி ஷார்ப்பா அப்படி கிளிக் பண்ணி நெக்ஸ்ட் கொடுத்தீங்கன்னா வேலை முடிஞ்சு போச்சு. கரெக்டா அவசரப்படக்கூடாது. ஓகே. ஃபர்ஸ்ட் நம்பிக்கை பேட்ஸ்மேனே டக் அவுட். என்ன பண்றது? பரவாயில்ல, பார்க்கலாம், டெஸ்ட்ல பார்க்கலாம். ஓகே. பிஜேடி வந்து இது வந்து டிரான்சிஸ்டர். ஓகே. தென் the prefix will be what type of coupling I am going to introduce. Okay. So நான் எப்படி நேம் பண்ண போறோம்னா coupling and the device name. With this we will with the help of these two we will spell the type of amplifier. Also if you want to add number of stages you can add. Okay. Here 3 stage, ரொம்ப simple. I have 3 transistors. That's all. And also this setup you know very well. These are all our amplifier setup. What type of biasing they used in this circuit, sir? What type of biasing? What type of biasing they used? Can you take it as a revision? Take it as a revision for your module 2. See, here in multi-stage amplifier, we stick with only BJT, not the MOSFET or MOSFET. Okay, wow. Okay. So the 3 stage into the clear theory. Now we will see a few more concepts in detail. So here the input signal we are going to give. Here we are going to take the output. Okay. Yes. Then gain we discussed. I think I gave few examples. If you consider 2-stage amplifier, the first stage having the voltage gain of say example 10. The second stage having the voltage gain of 2. And I am giving the input voltage as 1 volt. Can anyone tell me what will be the output of my first stage? First stage la measure panna, what will be the magnitude of the voltage at your output of the first stage?
10.
Very good. It's 10 volt. Now the 10 volt is given as the input for the second stage. Yes, tell me what will be the output of the second stage or the output of the entire system?
20.
20. How you have calculated this? Simple multiplication. Am I correct? Simple multiplication. That means what? Input voltage into the gain will give you the output. In other words, voltage gain is equal to output voltage divided by input voltage. Very simple. Now you try. Now you try. What will be the overall gain of the amplifier? Overall gain.
90, sir.
How I can find overall gain? See, overall gain, voltage gain is equal to my output voltage 20 divided by my input voltage, it is 20. What is the unit of this? What is the unit of this? It is a unitless quantity. But yesterday we have discussed one thing. We will convert the voltage gain into decibel in some condition because sorry, yesterday. Okay. The class at the confused. Not yesterday's class. Okay, in previous discussion we have told that we will convert this voltage gain into decibel. Why? See, my operation amplifier is going to give only voltage, but I'm going to connect this voltage into my speaker. So speaker it will produce some energy that will transmit it. Then I will hear this energy. What type of energy we are using to transmit between the speaker to my ear? What is the energy we are going to use it? It is electrical energy. Is it we are using sound? Am I correct? So it is better to always have this conversion also in our amplifier will give some good understanding of what is the power of your amplifier. Therefore, the scientist will do one thing. After this electrical kind of thing, they will include your what? So the physical quantity of this sound also. How to convert it to decibel? Anyone remember the formula? 20 log of your this voltage AB. This will give you what? Voltage gain in decibel. Very simple. 20 log base 10. Okay. 10 voltage gain. So if you now you put, you need to address the unit as decibel. Okay, va? So amplifiers simply voltage gain sonna, it is a unitless quantity. If I convert it into sound energy na decibel la rotate panikkanom. Okay va sir? Yes. So as a conclusion, if I want to find the gain of the multistage amplifier, very simple. My gain is equal to gain in first stage into gain in the second stage. If I have more than 2, this will be my general equation. Am I correct, sir? Keep on, I can multiply. Okay. So check pani parunga. 10 into 2. 10 into 2. How much? 20. So our answer is correct. Okay. So this is the idea behind how to calculate the gain in your multi-stage amplifier. Please note down this. Sir, can anyone tell me how this multiplication is converted into addition? How the multiplication is converted into addition?
Log of
log of any multiplication you can convert it into log of the particular value plus
A
plus
log
you
of
can
B.
Yes, you can do that. You know analytically how it is valid. Am I correct? Yes, please note down and say yes. Thereby we will move to the next slide. ஆனால் நிறைய பேர் நினைப்பான் சார் நீங்க பாட்டுக்கு நெக்ஸ்ட் ஸ்லைடுன்றீங்க எவன் சார் ஆன்லைன் கிளாஸ்ல எழுதுறான். I forgot to show this sample class note. I shown this to some other classes, but I forgot to show this to our class. See how your friends are listening the class and taking the notes. நிறைய பேர் நினைச்சிட்டு இருக்கிற ஆன்லைன் கிளாஸ்ல எல்லாரும் சும்மா இருக்கா, யாருக்கும் வேலை கிடைக்காதுன்னு. Be careful. Many of them taking these classes very attentively and they are learning the concepts very detailed. Okay, definitely these people will sit along with the circuit branch people. Definitely these people will kill their job. Okay, but எப்படி எழுதிருக்காங்க பாரு நோட்ஸ், நம்ம இங்க ஒரு கோடு போட்டா அங்க நோட்ல கோடு இருக்குது. ஓகேவா? see இவங்கெல்லாம் என்ன பண்ணலாம்னா காலையில எந்திரிச்சு நோட்டை ஒரு லைட்டை அப்படி டேர்ன் பண்ணாங்கன்னா சஃபிஷியன்ட் ஃபார் தெம் டு ப்ரிஃபேர் ஃபார் தயர் டெஸ்ட், பிகாஸ் எவ்ரி திங் ரிட்டன் பை தெம், தயர் ஹேண்ட் ரைட்டிங். ஸோ நம்ம பிரெயின் ஆல்வேஸ் நம்ம ஹேண்ட் ரைட்டிங்ல இருக்கிற கண்டென்ட்டை குயிக்காக உள்ள எடுத்துக்கும். ஓகேவா? அவர் எவ்வளோ நீட்டாக எழுதுறாங்க பாரு கிளாஸ் நோட்ஸ். நீ சார் ஏதோ கொஞ்ச நேரம் டைம் கொடுக்குறாரு, எடுத்துட்டீங்கன்னா நெக்ஸ்ட் சொல்லுன்றாரு, எவன் எழுதிட்டு இருக்கிறான், நம்ம ரெஸ்ட் எடுக்கலான்னு அங்கே உட்காந்துருக்காரு. ஓகேவா? அவங்க பாரு கொஞ்சம் கிளாஸ் ஃபாஸ்டா போகும்போது ஒரு டெக்னிக் எடுத்திருக்காங்க பாரு, எவ்வளவு ஸ்மார்ட்டான டெக்னிக் பாரு. Can anyone tell me what it is? This is not a hand written one. Am I correct? Correct? So Can anyone tell me what it is? Is it you, everyone having this kind of content in your hand? Irka sir, hello?
Yes.
Enna content sir idu? Enna content? It is your handout hard copy. Am I correct? So everyone having this hard copy. This particular student, what she or he did, she, I think she is having the handout nearby with her or he while he is attending the class. Whatever the thing already present, he or she not returning the same thing. He's not downing only new things what we are teaching. அதில் எங்கென்னலாம் நியூ இருக்கோ அந்த பாயிண்ட் மட்டும் எழுதியிருக்காங்க. This is also one way to take the notes. அதுக்கு நீ ஹேண்ட் அவுட்டை ஃபுல்லாக எடுத்து கிறுக்கி வச்சிடாத, புரியுதா? அப்புறம் if others are reading, they may find little difficult. If you want to give this same material to your youngers, ஸோ அவங்களுக்கு இந்த கிறுக்கி இருக்கும்போது கொஞ்சம் படிக்க கஷ்டமா இருக்கும். ஓகேவா? பட் டோன்ட் வரி, யூ ஹாவ் அ சாஃப்ட் காப்பி, யூ கேன் கிவ் இட் டு தெம் டு ஸ்டடி. ஓகே, ஸோ திஸ் கைண்ட் ஆஃப் திங்ஸ் ஆர் ஹேப்பனிங் இன் யுவர் கிளாஸ். நீங்கள் எல்லாம் வந்து ரிமோட்டில் உட்காந்துட்டு இருக்கிற, மற்றவங்க என்ன ஆக்டிவிட்டி பண்ணுறாங்கன்னே தெரியாது. அதனால தான் ஒரு எக்ஸாம்பிளும் உனக்கு காட்டியிருக்கேன். சரியா? நீ பாட்டு நினச்சிட்டு இருக்காது எல்லாம் ஸ்க்ரீன்ஷாட் போட்டு தான் உட்காந்துருக்கான் அப்படின்னு நினச்சிட்டு இருக்காத. ஓகேவா? எஸ், ஹாவ் யூ நோட் டவுன் திஸ்? அட்லீஸ்ட் இன்னையிலேருந்தாவது கொஞ்சம் ரியலைஸ் பண்ணி எழுத ஆரம்பி. ஓகேவா? எஸ், ஷால் யூ மூவ்? இந்த ஸ்லைடுக்கு வந்து நிறைய டைம் எடுப்பான், எழுதுற மாதிரி நடிப்பான். கரெக்டா? சரி, ஓகே. நெக்ஸ்ட், coupling schemes and methods. Okay, we have discussed. Can you recollect the methods what we have discussed? One is the known one to everyone. What is that? Coupling is not a new term. Coupling is not a new term. Maybe yesterday or early morning you may studied your small signal amplifier. In the small signal amplifier circuit itself, before connecting the input and output devices, we will include one component between your amplifier and your input output. What is that component? Capacitor. What is the name of these capacitors? Can anyone tell me, sir? What is the name of these capacitors?
Coupling capacitors.
Coupling, input coupling capacitor, output coupling capacitor. What is the purpose of this? It is going to couple your input with your amplifier input stage. Then this capacitor is going to couple your output stage with your output device. Sir, if I want to transfer electrical energy, I can connect on single wire between this two. Simply it will transfer it will make a coupling. Am I correct? Yeah, wire use pannala. Why they are using the capacitor?
So to block DC currents.
See this particular fellow. See, this conductor fellow have a constant resistance. The resistance won't vary. So theoretically 0 ohm. Practically, if you measure, you may have 0.001 ohm or 0.0 ohm, depends on the conductor size and the remaining things. Okay, but this capacitor fellow have the name called reactance. So resistance offered by the reactive elements are called a reactance. So capacitive reactance unakku theriyum, this XC. So XC is equal to 1 divided by 2 pi FC. So these fellows are fixed to 1. The frequency is 1, is a variable. Okay, so how to differentiate my DC and AC? DC, here the frequency is 0. In AC I have certain frequencies. Most probably in the signal systems and all, that will be in the kilohertz and megahertz. So these capacitors will help to block one quantity and allow other quantity. So it is not possible with the single conductor. This is the idea behind why we use the capacitor there in the small signal amplifier. But here I am going to have Again, such kind of things as a amplifier as a one stage and another stage. Here also you are going to have input device and output device. So obviously before connecting the input, we will introduce one capacitor, and also before your output you will connect one capacitor. No doubt in that. But if I am having two different amplifiers, again I will bias these things with the biasing voltage. This will be the common bias voltage. Okay. Here, can anyone tell me, is it you need any coupling between these two? If so, what is the reason from your point of view? What is the reason from your point of view? Why you need to include something between these two? First and foremost thing, to transfer the energy from this circuit to this. Obviously, I need a coupling. That is the first point. What may be the second from your point of view? Can anyone tell me why you need to have a coupling unit between two stages? You can make an attempt, no issue. You can make an attempt, no issue. Yes? தூங்குறோம் சார் நாங்க எல்லாரும். நீங்க பாட்டு கத்திட்டு இருங்க. நாங்க நல்லா தூங்குறோம். Why? Yes?
To avoid DC.
To avoid DC, where to where you need to avoid? Where to where? This biasing voltage may get enter into your second stage. Am I correct, sir? Also, this in the second stage biasing voltage may get enter here. Nadakuma? Nadakuma nadakada? Is it possibility to mix these two? Biasing இப்படி mix ஆகுமா? இந்த voltages இங்க DC இங்க வரலாம், இந்த DC இங்க வரலாம். வாயே திறக்க மாட்டேன்னு நிக்கிறானுங்க. இந்த ஆன்லைன் கிளாஸ்க்கு many people were doing research. எப்படி வாயை திறக்க வைக்கிறது, எப்படி வாயை திறக்க வைக்கிறது. நாங்க பிராக்டிக்கலாவும் கண்ணில் காட்டிட்டோம். அப்புறம் இப்போ முடிஞ்ச அளவுக்கு அனிமேஷன் போடுறோம் ஸ்லைட்ல. இதுக்கு மேல உனக்கு என்னடா பண்றது? இவ்வளவு மௌனமா இருந்தீங்கன்னா என்ன பண்ணலாம்? நான் ஸ்லைடை மட்டும் அப்படியே மூவ் பண்ணட்டுமா? ஸ்கிரீன்ஷாட் எடுத்துக்கிறியா? நான் ஏன் கத்தி உசுர விடணும்? ஏண்டா? ஜெய்சு, நிரஞ்சனா தான் டெஸ்ட்னா வாய் திறப்பீங்கல்ல? ஹரிஷ், என்ன பிரச்சனை இன்னைக்கு? கிளாஸ் ரொம்ப ஸ்ட்ரைக்ல இருக்கு. டெஸ்ட் படிக்கிறீங்களா உட்காந்து? ஹலோ, நான் பேசுறது உனக்கு கேக்குதான்னு எனக்கு தெரியல. நீ பேச பாரு. 10 நிமிஷம் கழிச்சு எவனா வாட்ஸ்அப்ல மெசேஜ் போட்டு பார்த்துட்டு வந்திருக்கான் ஜெய்ஸ். டே சார் வாட்ஸ்அப் போட்டிருப்பான். ஐயோ கிளாஸ்ல கூப்பிட்டாங்களான்னு வந்திருப்பாங்க. நான் ஜீவனே வாட்ஸ்அப்ல பிபிடி போட்டு உங்களுக்கு எல்லாம் எடுத்துன்னு வச்சுக்கோங்க. எல்லாரும் பார்த்துக்கிட்டே இருப்பாங்க. இல்லை இன்ஸ்டாகிராம்ல அப்படியே கலரா இன்ஸ்டாகிராம்ல ஸ்டேட்டஸ், ஃபர்ஸ்ட் லைக், செகண்ட் அப்படி போட்டா எல்லாம் கவனிப்பேன்டா. என்னடா பண்றது நான்? ஐயோ கடவுளே, அது மாதிரிலாம் டெக்னாலஜி இன்னும் வரல. அப்படி வந்துச்சுன்னா நம்ம என்ன பண்ணிக்கலாம்னா, ஆன்லைன் லைவ் கிளாஸ் இன் இன்ஸ்டாகிராம். நான் அப்ப இன்ஸ்டாகிராம்ல போடும்போது இவன் கூகுள் மீட்ல உட்காந்து ஓடிட்டு இருப்பான். சரியா? நீ என்ன பண்றியோ அதுக்கு ஆப்போசிட்ல பண்ற அப்படின்னு நிக்கிறான். என்ன பண்றதுன்னு தெரியல. எப்படியாவது படிச்சு வேலையை வாங்குங்கடா. சரியா? நானும் கொஞ்சம் அளவா கத்துறேன். நீ ரிப்ளை பண்ற மாதிரி தெரியல. சரியா? நோட் பண்ணிக்கோ. ஆர்சி கப்ளிங், டிரான்ஸ்ஃபார்மர் கப்ளிங், டைரக்ட் கப்ளிங். நோட் பண்ணிட்டியா? நிறைய பாயிண்ட் சொல்ல வந்தா விட மாட்டேன்றாங்க. சரி விடு. இது என்ன சொல்றாங்க? அவுட்புட் ஆஃப் ஒன் ஸ்டேஜ் டு த இன்புட் ஆஃப் த நெக்ஸ்ட் ஸ்டேஜ் என்ன பண்ணணும்? லிங்க் பண்ணணும். அதுக்கு ஃபர்ஸ்ட் கப்ளிங் வேணும். அண்ட் ஆல்சோ prevents the shifting of Q points. அப்படின்னா என்ன மீனிங்? Each and every stage amplifier having certain operating point. In the stage you have one operating point, here you have one operating point. So these individual operating points should not get disturbed. எல்லாம் ஆல்ரெடி படிச்சாச்சு கீ மூலையே. ஓகேவா? ஸோ இந்த ரெண்டு மெயின் டிசிஷன்ஸ் எடுத்துக்கோ. 3 டைப்ஸ் நோட் பண்ணிட்டு ப்ளீஸ் சே எஸ். என்னலாம் பண்றாங்க? என்ன சார் ஓகேவா?
Yes, sir. Completed, sir.
நீ ஒருத்தர் ரெண்டு பேர் வாய்த்தாடா மொத்தம் பூரா தூங்கிட்டு சரி விடு நீயாவது கொஞ்சம் ரெஸ்பாண்ட் பண்ணிட்டு இரு கடைசி வரை கிளாஸ் முடிச்சிடலாம் சரியா சரி ரெசிஸ்டன்ஸ் கெப்பாசிட்டன்ஸ் டிரான்ஸ்ஃபார்மர் டைரக்ட் கப்ளிங் ஓகே எனி ஐடியா அபவுட் திஸ் டேர்ம் transformer? So transformer I already studied in my school days 12th standard in the electromagnetism. There are two windings. Already we named these windings in the school day itself. Can anyone tell me what is the name of this, sir?
So primary winding.
Primary and secondary winding. So primary winding is the one in which you will connect the input. Secondary winding is the one in which you will connect your output load. Okay, va? So what is the there is no connection between these two winding. There is no electrical connection between these two. It is isolated. Then how the electric energy is transferred from here to here? I think it will how it will jump from here to here. Is it any bridges available between these two? Yes, there is one bridge available. Can anyone tell me what is the name of the bridge?
Sir, inductance.
Not an inductance, it is an magnetic field. In a field? It is not electric field, magnetic field. So magnetic, that story and all we are not going to discuss much. Okay, you should remember one thing. There is no electrical connection between these two windings. So thereby I will get electrically isolation. Am I correct? It is not electrically connected. Okay, sir? And it is very easy. You know that DC, if I give DC supply to this system, plumbing, the induced EMF ஒருத்தர் கண்டுபிடிச்சார் Faraday's law of electromagnetic induction. அவர் என்ன ஃபார்முலா சொன்னார்? E is equal to N into d phi by dt ன்னு சொன்னார். கரெக்டா? d phi by dt. When you will have the change in flux with respect to the time, if you apply the change in voltage to the circuit, you will get the change in flux. If I apply DC, whether it will produce any induced EMF? No. So if I use transformer, the device itself won't transfer the DC supply. Ultimately, I will get the isolation of DC. Thereby, I can eliminate the Q point shifting. That's all. That is the idea behind this. Direct coupling. இவங்களே ஒன்று சொல்லுவாங்க, அப்புறம் இவங்களே திரும்ப கப்ளிங் வேணும்னுவாங்க, அப்புறம் டைரக்ட் கப்ளிங்கிறாங்க. ஏன்டா கன்ஃபியூஸ் பண்றாங்க? Don't get confused. There are some applications you can use direct coupling. That means you no need to use any coupling elements like a resistor, capacitor or transformer. Straight away you can connect the two stages. But you should know where you need to use such kind of circuits. Okay, that we will discuss now. I hope it is clear to everyone. Yes. RC coupled transistor amplifier. Okay, they're given little features. Please note down. The first one வந்து used for voltage amplification. So amplification we are spelling many times. In the electrically we have many quantities like a voltage, current and power. I hope you know these quantities. Am I correct? So even if you observe many of the speakers, they will give only the power rating. So that the amplifiers will do these three kind of applications: voltage, current and power. There are few amplifier circuits will do the mixture of these quantities. Say example, voltage and current, voltage and power. Like that there are few circuits available. Okay, but we will stick with the voltage amplification in this type of coupling. So RC coupled are suitable only for voltage amplification. That is the very simple key point you can note down. And also this coupler is popular because it is cheap. வெறும் cheap னு சொன்னா இது கூட கம்பேர் பண்ணி தானே சொல்லணும். Wait for some time to listen for the next type, then we will compare this point. At this point of time, take down the keyword as a cheap. Secondly, it gives excellent audio fidelity. That means audio song input la kodutha output la nalla clear ah kekum. Okay va? Yes. Note down this. Note down these key points. RC coupled is cheap, but I don't much clarity in this. Then it is giving good excellent audio output. Then voltage amplification. So these are three key advantage of your RC coupled and RC coupled transistor amplifier. Is it clear, dear students, how we are going to name hereafter the amplifiers? Purinjircha? How we are going to name the amplifiers hereafter? We are going to include the what type of coupling you are going to have. Okay, yes. Take down this circuit and also tell me how many stages are present in this circuit, sir?
2.
Two stages were present. Okay. RC coupled, sir. We know this capacitor is aids to couple my first stage to my second stage. This is clear, sir. Then why it is named as a R? So here, while they are discussing about the coupling, they are taking one more component is also into account. That is this resistor. So this capacitor and this resistor together is going to be considered as a coupling unit. That means this R2 resistor have two functions. What is the first function? Voltage divider. Am I correct? Two role correct. What is the second role? What is the second role of R2? Coupling. Okay, ma? Please note down. So due to the reason, this is also called as a this is hereafter is going to be called as a RC coupled transistor amplifier. I hope no doubt in this. Take down the diagram. The diagram within 1 minute you need to finish this diagram. Tuck. Quick. Yes. So these are all old stories. What is this to? What is this to, sir? This is your
input coupling.
This is your
output coupling.
Okay. This is the RC coupling. My diagram mark you no need to read the sentence. Just watch the diagram and turn the page and go to the next slide. Okay. Yes. The theory எல்லாம் மேல இருக்குது நோட் பண்ணிக்கோ. புரிஞ்சுச்சா? இங்க வந்து ஷண்ட் ரெசிஸ்டன்ட்றாங்க. ஷண்ட்னா என்ன மீனிங் சார்? ஷண்ட். ஷண்ட்னா
நல் ஒண்ணும் இல்ல மட்டும் சார். parallel, sorry.
Sorry, parallel. Very good, parallel. Okay va? Shunt means parallel. The new term எனக்கு டஃபா இருக்குன்னா அடிச்சிட்டு parallel எழுதிக்கோ. அதுக்கப்புறம் ஷண்ட் உள்ள கொண்டு வந்துக்கோ. ஓகேவா? ஷண்ட்னா எப்படி சார்? See, this is my input zone. That is my base emitter. Base emitter கூட அந்த R2 எப்படி கனெக்ட் ஆயிருக்கு? Parallel. Am I correct? Parallel இருக்காது. அதான் அந்த ஷண்ட் ரெசிஸ்டர். Note பண்ணிக்கோ. Say yes. Thereby we will move. Quick. Yes. Yes. The next one, the particular type of RC coupling, you have one small drawback. Okay, drawback are the impact of this one. So what is that means? An RC coupled amplifier will have low voltage and power gain. Low voltage and power gain means ரொம்ப simple. See, these two we will measure only in the output. Am I correct? We will compare with our input and output. So we are giving something and we are amplifying into some extent, then we are receiving at the output. But that amplified effort is little affected because of this kind of coupling. So what is that? What is that? In this kind of coupling, the effective load to AC, that means here you are going to give the AC signal. These whole things going to be considered as a load for my AC. Am I correct? So if the effective resistance of this particular circuit is low, as per George Siemens ohms, he found the relation that I is equal to V by R. If R less, current will get increase. If current getting increases, it will in turn will make the voltage drop to increase. If the system itself will consume little voltage drop, what will be my output? There will be a little reduction in my output. Actually, I need to get this, but because of this kind of coupling, I have a little reduced voltage. If you measure the power gain also, power gain and sir, power gain and first you know what is power. Power is equal to V into I. You know the voltage gain. Am I correct? So voltage gain, if you multiply with the current, you will get the power gain. Even you can draw the power waveform also. Okay. So what is the takeaway point here? Very simple. RC coupled circuit will create effective load resistance to low to your AC signal. Or AC signal it will produce low effective resistance. Here R AC கொடுத்திருக்காங்க ரொம்ப simple. If you are discussing about regarding this AC signal, you need to consider RAC. If you want to discuss about the DC signal, you want to discuss about the RDC. Okay, don't get much confusion. Take down only these keywords and we will move from here. Little low voltage gain வந்து கொஞ்சம் கம்மியா இருக்கு. ஓகேவா? Yes. அப்ப என்ன பண்ணனும்னா scientists they will introduce some other gain, say some other coupling to improve this. Correct? First they will invent something, then they will find the drawback in that, then they will overcome the drawback with the help of the second one. Again the second one may have some drawback, then what they will do, they will go with the third one. Am I correct? Yes. Then the next one, application. Yes, this is very very important, sir. Note down. You know that this RC coupled is famous for voltage amplification, therefore it is used in voltage amplifiers. Example, initial stage of public address system. It is in short will be called as a PA, public addressing system. Your mic, amplifier, speaker and some associated thing related to this audio is called as a public addressing system. Don't think it is a very little area. Okay, here whatever the speaker and mic have it in your hand is different from the A.R. Rahman Studios mic and speakers. Am I correct? There they will have few more digital components. That is the one of the music player, music director introduced many technologies. அதனால தான் அவர் குருல இருந்து அவர் கொஞ்சம் டீவியேட் ஆனார். அப்புறம் ரெண்டு பேருக்குள்ள ஃபைட் எல்லாம் வந்துச்சு தெரியுமா? ஸோ அந்த பர்டிகுலர் மியூசிஷியன் வந்ததுக்கு அப்புறம் தான் he introduced many instruments. ஓகே, அவர் ஆர்கெஸ்ட்ரால பார்த்தா ஸ்ட்ரென்த் கம்மியா இருக்கும். ஏன்னா These circuits itself will make some sounds. So they can replace the person with the circuits. Okay, va? Yes, vandrunga. Idhula ore oru takeaway point is initial stage. Idu mattum note panikko. What is the meaning of initial stage? See, if I have three stages, first and second and third, this RC coupled amplifier have little disadvantage. You know, no, this will reduce your voltage gain. So therefore, what they are doing, they are going to use this RC coupled amplifier only in the initial stage, maybe 1 and 2, or in the first stage. That means the third stage and second and third stage will be occupied by the some other type of coupling. Don't worry, that is our next type we are going to discuss. Okay, yes. Yes. Next type, transformer coupled transistor amplifier. Okay, sir, transformer one is connect pandrathu. I have R1 resistor, R2 resistor, RE resistor, RC resistor, and output terminal where I have to connect my transformer. Can anyone tell me where, if you are provided with this circuit, where you will connect your transformer? Can you imagine by your own? நான் வந்து இங்க நான் இந்த பாயிண்டர்ல வரையறதுக்கு இவ்வளவுதான் டைம் எடுக்குது. நீங்க அப்ப எவ்வளவு ஸ்பீடா வரையலாம்டா சொல்லுங்க. வேர் யூ வில் கனெக்ட் யுவர் டிரான்ஸ்ஃபார்மர், வெதர் யூ வில் கனெக்ட் இட் R1, R2, or R collector or R emitter, where you will connect, or in the output terminal. போன கிளாஸ்ல காட்டிட்டேனடா. Okay, this is your assumption. Okay, if you are going to replace this RC, very good. Our answer is solitaire, correct? RC. Okay, tell me, you have two things in your transformer. One is the primary winding, another one is the secondary winding. Okay, primary winding you call it as the P1 and P2 terminal. Secondary winding S1 and S2. Where you will connect P1 and P2 and S1 and S2, please? I removed this collector. Okay, here I have two vacant, two terminals. How you will connect this transformer to here? Shall I? Okay, input la vandu P connect பண்ணியாச்சு. Then
output S1 and S2 to
another block. Very good. Next stage. That's all, your honor. Check your diagram. Is it clear, sir? Is it clear? See, if you compare, what to compare? Just now we discussed one thing, that is your RC couple, and now we are discussing transformer. Okay. So what is the good practice? Always left hand, right hand. Keep one thing, known thing in the left hand, take the new thing in the right hand. Wait a minute. Yes, compare these two. So here we removed what? RC resistor we removed. In place of RC, we are going to keep the primary winding of your transformer. That is the first difference. What is the second difference? We are going to remove one more component. Can anyone tell me what it is? Output coupling capacitor you need to remove. Then how I can couple? See, the transformer itself, you have one more winding, secondary winding. So if I give it to here, ultimately I can get output to here. So I can connect the secondary winding terminals to my next stage. But then I have one small doubt where to connect. See here the ground is common for all the stages. Here also the ground is common. Then the one end of the capacitor is connected in the first stage, the second end is connected to the second stage. But here you observe I have two terminals. And then where to connect these two? Closely observe. One you need to connect at the common bit terminal between the voltage divider resistors. This is the first point. Second point, I need to connect it to the base terminal of my transistor. Okay, this connection is removed. This junction connection is removed here. Check pannina inga oru valaiva theriyum. Can you observe this? Can you observe this bend? That means what? Jump pipe. There is no connection between these two wires. These two wires. Okay, my sir? So these are all the changes between these two and what, and this capacitor also removed. This also removed. This is replaced with one more coupling transformer. Here the beauty is that the output is connected in the secondary winding itself. But if you observe in the previous, we will connect output over here. So these two are the major difference between your RC coupled and what? RC coupled and transformer coupled. Do one thing, evening sit, after you see it is next CA prepare panna, free time la put on tabulation, draw this diagram, draw this diagram, and take all the points under these diagrams. Okay. Yes. Now we will come back to our discussion. RC coupled.
Sir.
Yes, sir.
Sir, the transformer is primary, secondary, number of windings in the same amount.
Yes. Ajit, that is a different story. Now, based on the number of turns in the primary, secondary, step up, step down la nariya kadai irukku. Correct? Same voltage. Inge rendu turns, inge rendu turns. 1:1 ratio. 1:1. Okay, 1:1. Same. Okay, va? அதெல்லாம் உள்ள போனா அப்புறம் நிறைய பேர் டென்ஷன் ஆயிருவாங்க, அதெல்லாம் வேண்டாம். சரியா? Then the name of the transformers are called as what? Coupling transformer. In between la irundhuchina, between the stages, இதுவே output stage la இருக்கு, last stage la இருந்தா, that is called as a output transformer. Okay ma? Is it clear, sir? Is it clear?
Yes, sir.
Okay. Yes, sir.
இங்க பாருங்க, அப்படியே vice versa பாருங்க. Effective load resistance in each stage is increased. But in the previous case நமக்கு என்ன பிரச்சனை? What is the drawback in the previous case?
Decrease.
Effective resistance decreases if you keep on add RC. Okay, so that disadvantage is overcome here. Please take down the diagram. Let me give 1 minute time to take the diagram. Quick. Module 3 இன்னைக்கு எப்படியாவது ஸ்டார்ட் பண்ணணும், அட்லீஸ்ட் இன்ட்ரோடக்ஷன். This story and all, no, very simple. Am I correct? Already we have discussed these stories. Note down. P primary winding, S secondary winding. Okay. Yes, shall we move? Sorry, those are not finished. Even you can refer the recording or your handout. Refer பண்ணி diagram finish பண்ணிக்கோ. சரியா? Then here, let me skip this line alone. The impedance changing property of a transformer, this low resistance, this sentence alone I am going to skip. You read it. If you want a clarification, stay back, I will explain. Okay. ரொம்ப ஹார்டா போச்சுன்னா அது ரொம்ப டிரான்ஸ்ஃபார்மர் கப்ளிங் எடுத்துருவேன் சரியா. This point if you want I will explain, but not now. Okay. Then where I am going to use this transformer coupling, it is generally employed in the whenever the load is small. Load is small now, what it means? Load is small. What it means? Load na enadhu? No. Load na load. It is not a voltage. Load அப்படினா இதோட பவர் ரேட்டிங்ல இருக்கலாம் இல்ல இதோட ரெசிஸ்டன்ஸா இருக்கலாம். ஓகேவா? ஓகே. So load வந்து small load க்கு தான் I can connect this in the I can use this type of coupling. Okay sir? And also this particular transformer coupling mainly used in power amplification. RC coupled mainly used in
voltage.
Compare பண்ணி படிச்சுக்கோ. ஓகேவா? Yes. Then example application where I can use it, last stage of multi-stage amplifier. Okay sir, very last stage they will introduce this. So in earlier discussion we discussed is 1 2 3 now. So அப்ப வந்து 1 2 RC யூஸ் பண்ணிக்கலாம், third வந்து transformer. Is it okay? Example loud speaker அப்படின்னா okay, loud speaker na volume கொஞ்சம் ஹையரா இருக்குறதா loud speaker. Okay sir? Yes. So this is your application of your transformer coupling amplifier. Okay, so amplifier almost we finished 2 coupling here. Now you people can buy these components and design your amplifier circuit and you can enjoy the audio. Okay, try pannu. Yes, because these projects and all not going to deal with the high voltage AC supplies. Okay, so this DC you use some 9-volt battery. This audio signal is your mic signal, that will be millivolt. So if you are doing any wrong connection also you won't get shock. Okay ma? But if you are using any AC to DC conversion, நம்மள பாத்தீங்கன்னா transformer 230 volt கொடுத்து 230 ல இருந்து rectify பண்ணி 9 volt யூஸ் பண்றீங்கன்னா you need to take care of this portion. Better you avoid, use some 9-volt battery and design this kind of circuits and check your outputs. Yes. Now direct coupled transistor. So direct coupled we will eliminate the coupling element. Okay, so coupling element eliminate panna, I told you already, it have many limitations. The first and foremost is the extremely very low frequency. That is the first limitation. And also this coupling is not used for your audio system and all. You can't use it in your audio system. You can use it in amplifying your photoelectric current and thermocouple current. Photoelectric current. What is the meaning? What is the name of the device? Can anyone tell me? What is this 2 arrow indicates? These 2 arrow indicates light energy. That is your photo, right? Photons base பண்ணி electrical energy. Okay va? இது வந்து here it will change some change in resistance. If I connect it in the circuit, So where I want to sense the output that will be in the very low magnitude. For that I need to introduce amplifier. One more thing is also available, photoelectric abdina. You have one more component, that is your PV cell, solar panel la paathirpa, correct? And also photodiodes. These are all some electronic devices will receive the photon as the input energy and it will produce some change in parameter. Here exactly you will get the change in output voltage. So this voltages will be very tiny, very lesser in voltage. So if you want to process these signals, that means always in any projects you will be having one microcontroller and some sensors. So these photoelectric currents will receive from the sensors. And also thermocouple Seebeck effect, two different metals and joining point. Here if you give heat, you will get some potential. Have you studied this effect in your school days? Seebeck effect and thermocouple. Am I correct? So these things will give very low voltages, millivolt, and some cases microvolt. These voltages are not sufficient to drive my system. Even my controller can't sense these low voltages. For that, I need to introduce one particular component between my controller and my sensor, that is your amplifier. Okay, so such kind of amplifiers you can design with direct couple. Okay, so இதை வந்து யூஸ் பண்ணி very high power போக முடியாது. First of all low frequency, then to amplify these kind of signals. ஓகேவா? Yes. வேற என்ன இருக்கு சார்? இங்க பாருங்க, செக் பண்ணி பாருங்க. This is your circuit diagram. Can anyone observe there is one major difference in this diagram? Can anyone tell me? Based on your transistor used, is it we are using same family of transistor in all the branches? What type of transistor it is? What type of transistor? Can you name the type of transistor?
Two common emitter and one common
this is
collector.
I am asking the type of transistor.
NPN and PNP. The center one is PNP.
This is
NPN.
Okay, wow. So in this type of direct coupling, we will use complementary. இங்க ஒன்று இருந்தா அதோட காம்ப்ளிமெண்டரி தான் அடுத்ததுல இருக்கணும். இதுக்கு அடுத்த ஸ்டேஜ் இதோட காம்ப்ளிமெண்டரி. ஓகேவா சார்? ஓகே. So this is a major difference in this direct coupling. Here we are using complementary transistors. Note down. First stage one, the second stage one. Then the third stage will be the different of this one. Okay, wow. So note down this. Here I am going to give input signal. Here I am going to receive the output signal. Okay. Then comparison. So comparison ரொம்ப simple sir. நம்ம last point check பண்ணிக்கலாம். This is used for voltage amplification. This is used for power amplification. This is used for amplifying extremely low frequencies. Based on the application. Now we will come to the space and weight. எதுல weight கம்மியா இருக்கும்? least-ஆ இருக்கும். So coupling capacitor, coupling components say absent in the last category. Thereby here it is least. In the first one, I am going to use the resistor and capacitor. The weight of the resistor and capacitor is lesser than your transformer. I hope you know this. Am I correct? Transformer edutha you will be having transformer. You will be having primary winding and secondary winding. This is your core. This is the core. Correct? It is made up of silicon steel. So the silicon steel weight jaasti. So on the particular thing that we have included in the symbol also. This is my primary winding, this is my secondary winding. No one asked what is this two line. What is this two line? This is your core of your transformer. So on the transformer core, இதெல்லாம் சேர்ந்து weight கொடுக்கும். Therefore, here it is least, here it is less, here it is more. Then these two are very similar. Cost, space and weight. Due to the transformer, cost high. Here I am not at all using any coupling elements, only the transistor, therefore it is least. Here I am using only resistor and capacitor, therefore it is less compared to the transformer coupling. Then the last one, the audio frequency la use pannalam. Okay va? Inga frequency response on the little poor, the best. This point we skipped. If you want, you ask at the end of the session, we will discuss. Okay? Can you note down this comparison? Purida? 3 slide, 3 different types. In that you need to make comparison by your own. But we gave little comparisons over here. You can add few more comparisons also based on the construction, operation, and so on. Yes. Then RC coupled two-stage common emitter amplifier, we are going to do some analysis. Okay. Don't worry. Already we finished this portion. And also we are going to write the exam for this portion. Correct, sir? We know analysis about this stage. This is the duplicate of your second stage. That's all. 1 plus 1. Together, if I add, my analysis parameters only will get changed, but the technique what we are going to adapt for the analysis remains same. Okay. So take down this diagram. This is your two-stage amplifier. The first and foremost thing is the known one to you, how to find the voltage gain. So I know I should calculate the voltage gain of the first stage, and then I need to calculate the voltage gain of the second stage. How to calculate the voltage gain? For that, I want to know what is the input voltage of the first stage and what is the output voltage of the second stage. Am I correct? Am I correct? So to find these parameters, I also need certain thing. What is my input impedance and output impedances? Thereby I can calculate these parameters, and at last we can come to this end result. You can get this gain. So that is the analysis what we are going to carry it out here. Okay. So the very first one, the gain note panitiyakana, the gain known to you. Am I correct? So thereby I am moving. So these stories and all, substitution from your diagram. So in the substitution, sir, name panikang check panikyo. R1, R2, first stage voltage resistor. R3, R4 are second stage. Okay. Then similarly RC1, second stage 2. So subscript they have added. Okay. That all is the change over here. Then what? We will take this circuit and we will observe the output waveform. Observe the output waveform. This is very important. So this is my input. So for example, we took it as a 1 volt. Am I correct? 1 volt. Upper second stage, there is a little amplification. So example, how much you got in our case? Okay, 10 volt. Second stage, 20 volt. You may remember what are the gain we gave. Am I correct? Here the gain 10. Here the gain is 2. That's all. Yes, there is a considerable amplification as compared with my input and output. I am happy. But what I need to little focus on these waveforms is this first, consider only this first half cycle. Consider first cycle, as you know, in the single stage amplifier, your waveform will invert Invert ஆயிருக்கா சார்? இங்க பாருங்க positive, இங்க negative. What is the angle of inversion? Can anyone tell me what is the angle
180.
of 180 degree? Again, I am going to give this negative to the second stage. This is inverted further. It is become positive. Is it clear, sir? 180, 180. What is the total shift between the first waveform to the last waveform? 360 degree. So it resembles my same input. It resembles my input waveform, but the change is the magnitude. Am I correct? Am I correct? Can anyone tell me if you introduce the third stage, what will be my output, sir? Only in the first cycle you tell, I will get the negative. Am I correct? Negative waveform. So that is the takeaway point in this two-stage amplifier. Note panni vechiko. So this is the first stage output. This is your second stage output. So this is the output waveform. Then what else? What else? Now only we are getting into the analysis. Don't afraid. Two part vandrum, H parameter vandrum. 10 மணி நேரம் கிளாஸ் இருக்குன்னு நினைக்காத. 10 minutesல முடிஞ்சிடும். Very simple. We limited all the things. We are going to show only the end result to you. That end result also easily understand by you. That is the beauty. Okay. So நம்ம என்ன பண்ணுவோம்? If you want to convert this circuit into equivalent circuit, we will replace our DC source and capacitors with short circuit. I hope you know what is the reason. Okay, DC வந்து we will switch off. DC off பண்ணிடுவோம். AC மட்டும் கொடுத்து we will do. That is your AC analysis. Okay. So DC you want to make it into zero. I can short circuit this source. That means the VCC கொண்டு வந்து ground to connect பண்ணோம். But in between இருக்கிற component ஓட I need to make the short. Okay. That means top you have one resistor, down you have R second resistor. So if I remove this and if I connect it here, these two resistors will be looks like parallel. Correct? மேல இருக்க resistor remove பண்ணி இங்க கொண்டு வந்து connect பண்றேன். அப்ப என்ன இல்ல, these two resistors look like a parallel. Sorry, not here. Here, இங்க இந்த R1 இங்க கொண்டு வந்தீங்கன்னா அது ரெண்டும் parallel connect பண்ண மாதிரி ஆயிடும். கரெக்ட்டா? The second thing, I need to short circuit these capacitors. Capacitors எல்லாம் தூக்கி விட்டுரு. Okay, now we will come to the equivalent circuit. ஆனா இது ஆல்ரெடி நம்ம பார்த்திருக்கோம். We know up to this. பொய் சொல்லாம சொல்லணும். கரெக்ட்டா? We know up to this. We are adding one more thing, that's all. Okay? Okay? What is the difference there? In the single stage analysis, we kept load here. Now we are going to shift the load to our output circuit. That is the only one change. Okay, sir? Yes. Penna sir analysis. The diagram allan note பண்ணிக்கிறோம். We will go through only these impedances first. ரொம்ப சிம்பிளா இருக்கும். Please observe. Input impedance, only these two resistors. This resistor, already this resistor is equivalent of my two resistors, R1 and R2 resistors. Due to that reason only I named it as R1 parallel with R2. Now the third one. So again the third one is also connected in parallel. Simply R1 parallel with R2 parallel with my H parameter. So Z in முடிஞ்சிருச்சு first stage. Z out. Where is Z out? This is my Z out. Z out, I am having only one resistor. Copy and paste it over here. That's all. Okay, sir. Then Z out of the actually this is the Z out of the second stage only. In the second stage or output மட்டும் எடுத்தா RC2. But if you take whole output with load connected, load connected ஆயிடுச்சுன்னா I need to consider this resistor also, this second resistor also. Now if I measure the Z out, these two are in parallel, RCL or RL parallel with RC2. அவ்வளவுதான் சார். வேற என்ன இருக்கு? I have two more things. Z in 2, Z into எங்க இருக்கு? இங்க இருக்கு. It is very much similar to the Z in 1. கரெக்டா? என்ன சேஞ்ச் ஆகுது? Only the subscripts. And the last one is what? Z out 1. Z out 1 எங்க இருக்கு? இது. அவ்வளவுதான் சார். All the impedance I know. I am happy. So if I know the impedances, it is easy to calculate the gain of the different stages. Note down these two end results, sir. Note down these two end results. From this, as we discussed earlier, from this we are going to find the overall voltage gain. That's all. Overall voltage gain. புரிஞ்சிருச்சா? கவனிச்சவனுக்கு புரிஞ்சிருக்கும். கரெக்டா? சரி. The last but not least, that is your Darlington configuration. This is the type of configuration. This is also like a direct coupling. Am I correct? But here the family of transistor is same family. Both are NPN. Okay. Listen. Here two transistors are connected back to back. Say example, the gain of this transistor is beta 1. This is beta 2. So first this will amplify little and it will give the input to the second transistor. Then it will amplify further and it will give the output to your circuit. Okay. So it's a very interesting one. Udayarajan having the same hardware in his hand. I think he connected 4 transistors. Am I correct, Udayarajan?
3 transistors, sir.
3 transistors. He made one YouTube video into a project. Okay, that we will discuss in the next class. Okay, at evening I will post that image and video to you people and observe. What is the beauty of this Darlington pair configuration is, especially this Darlington pair amplifier used in robot toy cars la use pannum. So the robotic toy cars la we will use DC motors. Correct, sir? DC motors use panni we will make the motor robotic car to move. So my microcontroller unable to give the sufficient current to my DC motors. Say example, my DC motor requires obviously minimum it requires 300 milliampere to drive with a low speed, minimum 300. But microcontrollers can capable of delivering only 20 milliampere. So obviously I need to amplify the current to some extent. Then only I can drive the DC motor happily to move my robo car. So this is the one practical application where we will connect our microcontroller in the input circuit and we will connect our DC motor in the output circuit. Everyone try to do this kind of some practical applications. Okay, there you can test your electronic skill as well as your programming skill. Okay, wow. So already in Tinkercad many of them trying that Arduino board. Am I correct? So Arduino la again you can form this kind of Darlington arrangement. There also you are having DC motor. Try to drive that one. Okay, with this pair and without pair. இது இல்லாம டைரக்டா DC motor கூட DC motor won't rotate. Then connect your transistor, then drive, then it will rotate. Do this exercise in your Tinkercad and share it. Okay. So here it is called as a super beta. Super beta and beta என்ன சார்? நீ பீட்டா டெல்டானா கன்ஃபியூஸ் ஆயிராது. இப்போ டிவில நிறைய சொல்லிட்டு இருக்கான். ஆல்பா பீட்டா டெல்டா. ஆல்பா கோவிட், பீட்டா கோவிட், டெல்டா கோவிட் எங்க கிரியேட் ஆயிருக்கு சார்? டெல்டா கோவிட். இப்படி ஒரு கண்ட்ரி இருக்கும். சாரி, நான் தப்பா வரையறேன்னு நினைக்கிறேன். டெல்டா கோவிட் எங்க கிரியேட் ஆச்சுன்னு யாராவது சொல்ல முடியுமா? இது என்ன கண்ட்ரி சார்? நான் அப்ராக்சிமேட்டா வரைஞ்சிருக்கேன்னு நினைக்கிறேன். இது என்ன கண்ட்ரி இது? இந்தியால கிரியேட் ஆயிருக்க கோவிடுக்கு பேரு டெல்டா கோவிட்னு அந்த வேரியன்ட். இதோட கெயின் பார்த்தீங்கன்னா ரொம்ப கம்மி தான். 50 டைம்ஸ் தான் கிரேட்டர் தேன் த ப்ரீவியஸ் ஆல்ஃபா பீட்டா கோவிட். ஒரு ஜஸ்ட் 50 டைம்ஸ் தான் அதிகமாக இருக்கு இந்தியாவில் இருக்க கோவிட். ஆனால் இந்தியாவில் மற்ற கண்ட்ரிக்கு அலோவ் பண்ணுறதுக்கு நிறைய இடத்துல பிளாக் பண்ணி வச்சிருக்கா. மினிமம் ஆஃப் இயர்ஸ்க்கு தெரிஞ்சுக்கோ, சரியா? கொஞ்சம் குயிக்காக நம்ம ரெக்கவர் ஆனாதான் வி வில் அலோவ் டு கெட் இன் டு த ஆன் சைட். ஓகேவா? ஸோ நம்ம இங்கே கிரியேட் ஆகிருக்க வேரியன்ட் வந்து 50 டைம்ஸ் அதிகமாக இருக்கா. அண்ட் ஆல்சோ எஸ்டர்டே தே ஃபவுண்ட் ஒன் திங், 1/8% கிட்ட வித்தின் 160 days ஆர் சம்திங். அது வந்து எவ்வளவோ டைம் அது வந்து சேஞ்ச் ஆயிருக்குன்னா அந்த நியூஸ் எல்லாம் படி. இதெல்லாம் இந்த செக்டார்ல தே ஆர் டூயிங் மெனி அனாலிசிஸ். நிறைய ஏஐ பிஐ எல்லா டெக்னிக்கும் இங்கே அப்லோட் பண்ணி மெனி ஆஃப் தெம் ஃபினிஷிங் தேர் பிஹெச்டி டியூரிங் திஸ் கோவிட். ஓகேவா? இந்த சயின்டிஸ்ட் எப்பவுமே பார்த்தீங்கன்னா இந்த இன்புட்ஸ் எல்லாம் அவனுக்கு ஒரு டிசீஸ் எல்லாம் அவங்களுக்கு பொறுத்தளவுக்கு ஒரு இன்புட் டு தேர் ரிசர்ச். ஓகேவா? நம்மளை பொறுத்தளவுக்கு அது ரொம்ப பெரிய பெயினா இருக்கு. ஓகேவா? சரி, இங்க வந்து என்ன சொன்ன பீட்டா, இங்க ஒரு சின்ன ஒரு டிராபேக் இருக்கு. லெட் மீ ஃபினிஷ் வித் திஸ். if I want to bias this, here one base emitter, here one base emitter. A typical base emitter voltage I know well, 0.7 volt. Correct sir? 0.7 volt. அப்ப together எவ்வளவு சார் இருக்கும்? பயாசிங் எவ்வளவு கொடுக்கணும் இன்புட்? பசி மயக்கத்துல இருக்க நீயே கூட்டி சொல்றான்னு சொல்ற. So 0.7 plus 0.7 is 1.4 volt is the typical base to emitter voltage required to trigger this. Is one little disadvantage. கரெக்டா சார்? கரெக்டா? இந்த பயாஸ் பண்ணா உனக்கு மினிமம் இந்த வோல்டேஜ் இருக்கணும், இல்லைன்னா உன்னால பயாஸ் பண்ண முடியாது. ஓகே, தட் யூ நீட் டு டேக் கேர். தென் ஒன் மோர் திங் என்னன்னா, சின்ஸ் இட் இஸ் டைரக்ட்லி கப்புள்ட், லீக்கேஜ் கரண்ட் கொஞ்சம் ஹையா இருக்கும் இந்த சர்க்யூட்ல. ஓகேவா? அட்வான்டேஜஸ் என்ன சார்? இட் இஸ் யூஸ்டு ஃபார் வெரி லார்ஜ் கரண்ட் கெயின் யூஸ் பண்ணிக்கலாம். அப்புறம் இன்புட் இம்பிடன்ஸ் is very high, output impedance is low. This story we will discuss in an elaborated way in module 3. With this I am going to conclude. Sorry I took 2 minutes extra. நீ கொஞ்சம் ஆன்சர்லாம் பண்ணினா கிளாஸ் கொஞ்சம் ஸ்பீடாக போகும். நீ பேசாம மடந்தையா அங்கே உட்காந்துட்டீங்கன்னா கத்தி டைம் தான் போகுது. சரியா? தேங்க்யூ வெரி மச் ஃபார் யுவர் பேஷன் லிசனிங். தயவு செஞ்சு காப்பி அடிக்காம டெஸ்ட் எழுதி என்ன ஆன்சர் என்ன என் மைண்ட்ல இருக்குன்றதை டெஸ்ட் பண்ணிக்கோ. இது வந்து ஐஏஎஸ் எக்ஸாம் இல்லை, காப்பி அடிச்சு ஏமாத்தாத. ஐஏஎஸ்